Good morning, good afternoon, and good evening to everyone joining us today. Welcome to another exciting episode to the Global AI Notes. We've certainly got an exciting lineup of speakers for you today. I'm certainly really very excited. So stay tuned and we'll bring the speakers on very soon. Hello, welcome to the Global AI Notes. We've got Leah, we've got Rob, and we've got Han Chi.
Hello.
How are you doing today?
Doing good.
So tell me, where are you guys joining us then today? Where are you guys from?
Yeah, I'm joining from Seattle, and my coworkers Hanchi and Rob, I believe, are also joining from Seattle today.
Lovely. Okay. Tell us a bit about yourselves. I'm very excited to hear you give us a talk on the code first approach in Azure AI Studio. But tell us a bit about yourselves.
Yeah, my name is Leah, and I'm a product manager on the Azure AI Experiences team. I was a developer for a while when I started at Microsoft and switched in the last few years to product management, which has been an exciting transition. And so I'm looking forward to sharing some of what we've been working on with everyone today.
Exciting.
Hi, I'm Rob Chambers. I'm an architect and engineering manager here in the AI platform division. Been at Microsoft a long time. Love bringing AI tech to our customers and to our partner teams to really materialize amazing experiences. Looking forward to the chat today.
Hello, everyone. My name is Henchi Wang. I've been with Microsoft for close to 7 years. Apologize for my setup for now. The traffic in Seattle is actually bad today, so I'm still in the parking lot of the office. I'll be in the office in like 2 minutes to join back to you guys. I just don't want to miss the start of the talk. But yeah, like I'm been working on the AI SDK and I'm very excited about the talk today.
Brilliant. I mean, I'm really excited to hear what you've got to say. So I'm going to pass the platform on to you, Leah.
All right. And let me know when the slides are showing.
You're good to go.
Okay. All right. So welcome to a developer's guide to Azure AI Studio. As I mentioned before, my name is Leah, and I'm a product manager on the Azure AI Experiences team. And I'm also joined by Hanchi and Rob, who will be helping out with questions related to the Azure AI SDK and CLI. We're going to go through an experience building kind of our own copilot here today, and then we'll have some time for questions at the end where we can dive a little bit deeper. Let's get started. So our goal today is to build a custom copilot code first using Python and the AI SDK and CLI. You may have seen how you can get started building your AI solutions in the Azure AI Studio, which is an exciting new capability that's been coming from Microsoft. Today, we're going to show you how you can get started developing code first as part of the Azure AI Studio ecosystem. By the end of this session, you'll be equipped to deploy and share your own enterprise-grade copilot grounded in your custom data. So in this session, we'll use a specific example for a copilot designed for a fictitious company called Treeholics. Our task is to build Treeholics a chatbot for their website to help customers figure out what products and services they want related to trees, landscaping, and gardening. Our Copilot code will be based heavily on a sample Copilot repository provided by Azure AI, but we'll adapt it for our use case. All right, so today we're going to build the backend of a web application. We won't explore implementing the web application part in today's session, but we're going to go through the structure of our API and this kind of backend application. This diagram shows the architectural design of an API that grounds our Copilot in custom data. This is known as Retrieval Augmented Generation, or RAG. We'll use the tools provided by Azure AI, including a hosted VS Code container pre-configured with the AI CLI and SDK packages. We'll use sample Copilot code and our own crafted data as the basis for our Copilot. So let's walk through how our program will work. A user will chat with our API from a web app. That web app will be consuming a managed online endpoint where we deployed our API. There will be a chat function that will take the list of chat messages from the user, and then our program will generate a vector representation up top here of the user's question using an ADA embedding model from the Azure OpenAI service. This vector will then be used to perform a vector search on an Azure AI search index we created that retrieves relevant documents from the user's query. Those retrieved documents and query context will then be sent to a GPT model. So we'll generate a prompt that will be sent to that model, and then we'll get an answer back. All of this is hosted within an Azure AI Studio project so that we have one place to organize all of the components of our application. So let's do it. Here are the steps we'll take to achieve our goal of building a custom Copilot grounded in our data. We'll set up our development environment. We'll build a search index from our data. We'll write custom Copilot code using a sample as our foundation. We'll evaluate our Copilot's performance using AI-assisted metrics. And finally, we'll deploy our Copilot to a managed endpoint in Azure. All right, here we go. So when choosing our ideal development environment, we have two main options for working with the AI CLI and SDK. We could choose to work locally and install the AI CLI and SDK packages in our local development environment. Or we could choose to work in the cloud by launching the AI Studio curated development environment for VS Code. Let's take a deeper look at these two options. To work locally, we'd follow steps outlining some efficient commands to install the AI CLI and the AI SDK. For more details on getting started locally, you can explore the documentation. Our other option, which we're really excited about, is to work code first by launching the AI Studio curated development environment for VS Code. On the screen here, you can see a preview of this VS Code environment. The AI CLI and SDK packages and prompt flow capabilities all come pre-configured in this cloud environment. Let's take a look at how this works. We'll start from the Azure AI Studio. Hopefully, the Azure AI Studio homepage is familiar to you. If you don't have a project yet, you'd get started quickly with the New Project button. In this case, I already have a project called Developer Copilot, which I can see here in my recent projects. Once you're in your AI Studio project, instead of navigating around the Studio UI, you could choose to work code first with the Open Project and VS Code button. You can choose either VS Code Web or Desktop, depending on your preferences. Let's stay in the browser for now. When you choose Setup on a compute, it gets configured with a curated environment as a container for VS Code to run in. The container comes pre-configured with the Azure AI capabilities we recommend using to build your Copilot through code. The first time you set up an environment, it can take a few minutes. In this case, we already have a compute set up, and we could go ahead and launch. Here we chose between different computes, but this experience also allows you to have different projects with their own environments running on the same compute. On launch, vscode.dev opens in a new browser tab. As VS Code loads, you'll see it'll show a helpful README file explaining how to make the best use of this container. In the File Explorer, notice that there's a code folder, a data folder, and a shared folder. The code folder is for storing your personal code files related to your project, and also where we recommend cloning repositories. This folder and any contents within it are persisted on the host compute, and commands will be performant. The data folder is the same. The shared folder contains files shared at the project level, so you can put code or data there that you want to share with others that have access to this project. And if you created any prompt flows in the Azure AI Studio, they would also show up there in a prompt flow folder. All right, so as we're setting up our development environment, we'll notice the README file suggested we clone a sample Copilot repo to get started. This is a public sample hosted in GitHub. As we build our Copilot, we'll follow steps and utilize tools defined in the sample repo that use the AI CLI and SDK, which are both conveniently pre-installed in this VS Code environment. In this preview, you can see we cloned the repository into the code directory of our container. We'll use this sample code as the basis for our custom Copilot. We'll be customizing a main script and adapting a chat completion function for our use case. Our next step for setting up our development environment will be to initialize the AI CLI. We recommend you run AI init before you start coding. Let's see a walkthrough. Because we are working in the curated container launched from the Azure AI Studio, our cloud development environment is already connected to our project and associated resources. We'll use the AI CLI to fully initialize our development environment. With a quick keyboard shortcut, Control Backtick, we'll open a terminal. As I enter AI init, you can see the interactive CLI experience pop up. Because the CLI is already configured for our current project in this cloud environment, AI init will just be a few steps. If you work locally, AI init will guide you through selections needed to connect your development environment to your project and associated resources. In this case, the CLI has found the current project and resources, and we simply confirm. In the next steps, we will select, or we could create, model deployments from the Azure OpenAI service that we'd like to use for our Copilot. We'll be able to choose from a list of the OpenAI model deployments available in our resource. First, we'll choose our chat completion deployment. Our option here is the GPT-3.5 Turbo model. Next, we'll choose an embeddings deployment that will vectorize our custom data. In this case, we have an ADA embedding model. Lastly, we'll choose an evaluation deployment, which can be the same as the chat completion selection, or whichever model fits best for your use case. If you haven't already attached an Azure AI search resource, AI init will help you do that. That resource will be used to host your vector index. As you can see, once the AI CLI has the selections it needs, it will hook everything up and your development environment will be ready to go. So let's review. First, we decided whether to use a local or cloud setup. To work locally, we would have followed straightforward installation steps for the AI CLI and SDK. After choosing to work in a cloud development environment, we launched it with one click, and it was pre-configured with the Azure AI capabilities. It was also clear how we could customize the container for our own use case. Okay. Next, let's build a search index based on our custom Treeholics data. So our Treeholics data is a combination of product data and customer sales data. We'll create a Copilot Treeholics folder in the code directory and copy the foundation code from the sample repo we cloned before. We can also see a snapshot of our data here. Your data could be formatted in many different ways, and by creating a search index, you standardize it for easy retrieval. We'll use the AI search command from the AI CLI to ingest the sample data and create a search index stored in our AI Studio project. The CLI will process the data and create or update the provided search index. We can see the expected output here. Next, we'll use the AI chat interactive capability to chat with our new index and sniff test its performance. Now that we've created a search index for our data, let's interactively chat with it via the CLI. This is a quick and easy way to validate our index, which is a critical part of building our custom copilot. In this command, you'll see we'll pass in our newly created index name and also the system prompt we want to be used, which I've currently stored here. It provides clear guidance for the chat responses. Let's go ahead and launch this chat. I'm going to ask it a general question about Treeholics. What products and services does Treeholics offer? The assistant comes back pretty quickly with a comprehensive response that references some of the documents that were returned. Let's see how it does with a more specific question. What is Treeholics' return policy? Great, we can see here that it's also retrieving information from the documents we indexed, and it gives a pretty clear and concise answer. Now that we've validated the index and chat capabilities, we're ready to code. So as we transition to coding, we'll want to prepare our development environment to connect to our new index. We'll use an automated CLI command to create a .m file configured with our environment variables, including our OpenAI chat and embedding models we selected before, and this new index that we created. AI Dev New has additional capabilities, which we'll cover a bit later, but we encourage you to explore the AI CLI's developer-focused features. So let's review. In 4 straightforward commands, we initialized our development environment with the CLI. We built a search index from our custom data. We interactively tested our new index. And we saved our environment variables to prepare for writing custom Python code. Great. So now we're ready to develop our custom copilot. So let's see some snapshots of code in the run.py file that we adapted from the AI Studio Copilot sample for our Treeholics use case. The run.py file first loads the .env we generated previously and will also import necessary system and Azure packages. We also adapted the sample code for just our Treeholics module. The sample offers some other implementations to explore as well. Later on, we'll look at customizing an evaluation and deployment function for our copilot. But for now, we'll focus on the code near the end of the main function, which takes a question and calls a chat completion method. Let's walk through the structure of this chat completion method, and we'll highlight ways we can customize it for our copilot. The chat.py file contains the chat completion method. This method leverages a defined chat protocol, which is a consistent interface across custom applications, Azure OpenAI, and other Azure AI Foundation models. First, this will take a list of messages from the user and get the last message in the conversation. And then it'll pass that to the getDocuments function. The getDocuments function uses the OpenAI SDK to first embed the question and then use the Azure AI Search SDK to do a vector search using the vectorized query and return relevant documents back. A bit later on, you'll recognize the same prompt from before, now formatted with a Jinja template. The template contains the prompt to the OpenAI model, as well as an instruction to return the list of retrieved documents as well. The response from the model is then returned to be passed back to the user. Let's see our code in action. Now that we have adapted the sample copilot code for our Treeholics use case, we'll test out our logic. The sample copilot code we used as our foundation implemented some CLI-like commands to make testing easy. We'll test our logic by invoking our run.py with a question. This will call our chat completion function and verify that our copilot correctly embeds the question, answers the question grounded in our custom data, and returns the retrieved documents. We'll likely get a good amount of content back, and I'll scroll up to the beginning of the response. There's some specific information returned here by our code, and we'll focus on the content returned in the message here. We can see that the question was answered correctly. If we look further down, we can also see the detailed documents returned as well. You may notice that this logic is similar to the interactive chat with our index capability that we tested before using the CLI. However, since we're now working with custom Python code, we customize this logic for our copilot. And we could go further if we wanted, adding calls to our own APIs, updating the prompt and parameters, or connecting to data from other sources, all to prepare our copilot for production use cases. If we wanted to test our chat completion function more interactively, we could do so via the CLI. AI chat gives us some useful examples. And the last example here, number 5, shows us how we would interactively chat with our custom function. So in our testing, we could see that a lot of context was returned. For our Treeholics copilot, we want to efficiently inspect the direct assistant response and know the token usage per query. So we'll adapt the sample code to leverage the usage field that is returned from the chat completion model to enhance our copilot response. We'll also remove the retrieved document context for more efficient querying in terms of speed and token usage, and also more efficient eye test assessments of the copilot responses. We'll see these changes in action later on when we deploy our copilot. Let's review. We referenced clear sample code structure and adapted it for our custom copilot. We connected to our search index and chat deployment via environment variables. And we implemented a predefined chat completion function for our copilot and used helpful arguments for quick step-by-step testing of our code changes. We're making progress. Next, we'll evaluate our copilot on some predefined metrics. Evaluation is a critical part of developing an enterprise-grade and production-ready copilot. At the core of the evaluation process is an evaluation dataset that can be used to test the copilot's performance. Here, we use an evaluation dataset which has example questions and ground truth answers about Treeholics that will be used to compare the copilot response and calculate how well it performs. You'll remember we picked the GPT-3.5 Turbo model to use for evaluation. In our code, we'll specify which GPT-assisted metrics we want to use. And we'll then assess the evaluation results and further iterate on our code and prompt to improve the quality of responses. Let's take a first evaluation pass on our copilot. We can see the metrics list from the sample copilot code defined in line 118. We know from our testing and evaluation dataset that exact match will not be a very useful metric for our Treeholics copilot. Let's replace it with GPT similarity instead. We'll use the handy evaluate argument the sample copilot code provided to run an evaluation. The path to the evaluation dataset was set in the code. While it runs, let's take a quick look at what is happening behind the scenes. The evaluate function defined in run.py will leverage the Azure AI Generative SDK package to load the sample evaluation dataset, and then take the chat function as a target along with the dataset, generating a set of AI-assisted metrics with which to evaluate the quality of the copilot responses. We can see below that the evaluation is in progress. We'll be able to view the evaluation results in a few different formats, including the tabular format returned in the command line, or the generated evaluation output files. These can be used to debug results and improve our copilot performance. Let's take a look at what we got. So we can see that this completed here, and we get a summary of our metrics. We can see the tabular result here, and the question, answer, and context, and we can see some details. Over here, we'll also be able to see the evaluation output was placed here. We also get a nifty link back to the Azure AI Studio to view the evaluation results with nicer visuals. It'll show us inputs, outputs, distributions, and additional breakdowns of our evaluation output. Let's take a look. All right, so we can see our groundedness, relevance, coherence, and similarity score, and a breakdown of each of the results. It's clear the copilot performed well in some cases and less well in others. So let's see what we can do to improve it. Let's assume we got some help from a coworker who is an expert in prompt engineering. They provided us a crisp and safe prompt we expect to be better than the one we had before. Let's switch out the prompts and evaluate again. This time, we're going to name the evaluation run for easy reference. We'll let this run and then move back to the studio to compare the evaluations. In the studio, we can compare these two evaluation runs and get clear insight into how the copilot performed with the updated prompt. Let's choose our two evaluations and select compare. Now it's set the baseline here to our original evaluation, just like we'd want, and now we can see the comparison to the new evaluation with the updated prompt. We can see some slight improvements in coherence and relevance, and maybe a slight decrease in similarity. So in some ways it's a bit better, but there's definitely more that we can do. There may be cases where custom defined metrics will be more valuable than the ones we explored here. Custom metric support will be coming soon to the Azure AI Code First experiences. All right, so let's review. After adapting our code to work with our evaluation dataset, it was straightforward to choose which GPT-assisted metrics we wanted to evaluate with. We saw immediate evaluation results in our development environment, and then leveraged a nice evaluation interface in the studio for observing metric trends and breakdowns, identifying room for improvement, and comparing evaluations. We're getting close. Now that we feel confident in our copilot performance, let's deploy it to an endpoint so that it can be consumed, either by other teammates or an external application such as our website that will host the copilot. So we're ready to deploy our copilot. We'll use the handy deploy argument the sample copilot code provided. We specify our deployment name in the command, and the code will do the rest. While it runs, let's take another look at what is happening behind the scenes. The deploy function will leverage the Azure AI Generative SDK package to deploy our code to a managed endpoint housed in our Azure AI project. It will take in the package context it needs and the chat function we defined, set up our environment variables, grab our secrets, and safely package it all up so that it runs the same in a cloud production environment as it did in our development environment. This can take a few minutes, so we'll skip ahead. Now that our copilot is deployed, we'll want to test it out. We can invoke our deployment with a similar handy argument. We specify the deployment name in the command and the question in our code. We customized our code here to return the assistance response and the token usage for a streamlined testing experience. We can see the return content containing the copilot response to our specified query and the usage details. Just like we did with evaluation, we can test our deployment with a more interactive interface in the Azure AI Studio. We'll head to the deployments page, where we can see our deployed Treeholics copilot. Let's test it out with another question. We'll provide the expected input, and we can see the structured result. Okay. We leveraged an all-in-one deployment process that handled our secret management, packaged up our code, and deployed it to a managed endpoint in Azure. We then verified in a couple ways that our code ran the same in the cloud environment as it did locally. All right, we did it. What do you think that we should name our Treeholics chatbot? Let us know in the comments. So far today, we've walked through an example of creating a custom copilot using retrieval augmented generation. But you may have slightly different use cases or unique needs for your AI solutions. You may find the following additional CLI and SDK capabilities helpful during your development. We didn't show it before, but the AI CLI also lets you chat directly with your chat completion function, which is more interactive than the way we did it previously by running our entire Python file. Additionally, the AI CLI offers tools to generate code for not only simple chat completions, but also streaming, function calling, and adding your data. So far, we've shown CLI capabilities that specifically target Python developers, but our OpenAI SDKs support many other popular programming languages as well. If you wanted to explore those, we recommend you use AI Dev New List, which will list these capabilities. You may recognize that we used AI Dev New already for generating our .m file. By running this command, you can see what Dev New offers. The CLI supports code templates for web page generation in JavaScript and TypeScript. Using that tool, you get examples of the foundational code needed to launch an interactive sample website for your chat capabilities. We also mentioned streaming and previously showed deploying a chat function that leverages a defined chat protocol. The AI SDK and CLI also support streaming responses token by token so that an interactive application or web browser can read and display the response in small pieces as data comes back. And as a reminder, anything supported in the AI SDK is supported via the AI CLI as well. So you can use whichever tool you prefer. There are planned upcoming features, including custom metrics for evaluation and multi-language support in the Azure AI CLI and SDK, so keep an eye out for those. All right, that was our Code First Developer's Guide to Azure AI Studio. The hope is that you now feel equipped to use the AI Studio, the CLI and SDK to develop your own custom copilot. We hope you also got a sense for how you can use the Studio UI alongside VS Code and the CLI and SDK for a hybrid development experience that gives you the tools you need when and where you want them. Head over to ai.azure.com to get started today, and you can also check out the resources shared in this presentation to dive deeper into the Azure AI capabilities. Thanks for taking the time to listen, and let's open up for questions.
Thank you very much for that, Leah. That was very, very, very cool. We've got Hunchy there, and we've got Rob as well. Let's just have a look at I think there has been a couple of questions that's come up. Right, our first question. When would you opt for a code-first approach as opposed to utilizing Azure AI Studio in the portal?
Yeah, that's a great question. I'm wondering actually, so that I can see and engage a little bit more, can we stop sharing the slides?
Yeah, absolutely.
Perfect.
There
And I'll
we
be
go.
able to see everyone's faces and see the questions.
Yeah. So the question is, when would you opt for a code-first approach as opposed to utilizing the AI Studio itself in the portal?
Yeah, so one of the great things about the Azure AI Studio and the ecosystem is that we're really targeting developers. But in this kind of new world of generative AI, a developer can have a lot of different personas. And we now have developers working in all aspects of AI from start to finish. So we really hope that the tools that we're offering let you choose the way that you want to work. And so what we showed here today was a little bit of a hybrid approach where you made use of some visuals in the studio, but we're able to really dive into the code and work comfortably in a VS Code environment. So the hope is that you're able to choose where you're more comfortable. And I think to more directly answer the question, our suggestion would be when you're looking for more visual experiences and more using an interface, that's when we would suggest using the studio. And when you want to be deeper into code and command line experiences and working directly with the SDK, we'd recommend the development environment. But again, we really hope that it's a personal preference that you can take advantage of.
Certainly, certainly just to add one more thing to that, the way I think the whole team looks at this is we're really trying to optimize to meet the customer where they are, to meet the developer where they are, and that is in their level of experience, their level of tool comfort, their their specific approach, their language choices, their platform choices, all of those things. We want to make it feel native to each person, whatever they need. We hope we've delivered it for them.
Yeah, agree with what Leah and Rob just said. And if there's one more thing I can add, that will be that a common pattern we see from customers is that they usually start from the UI when everything is more straightforward and visual. They can get started more easily. But when they want to fine tuning things even more and control more knobs or integrate things with their existing software or services, that's when they switch to code first.
Cool. In terms of, I've got a question actually. So in terms of the evaluations, right? Can you do an easy comparison using VS Code? Or do you have to flip back to the portal and have a look at the comparisons?
Yeah, so you're able to take multiple runs and compare them, but it's a little bit more of a manual process that doesn't have that same interface. That's definitely the kind of thing that we could consider trying to incorporate and maybe even make use of the relationship we have with the VS Code team to bring some capabilities like that. But for now, because that's more focused on kind of a visual comparison, we feel that that belongs more in the UI currently. But that doesn't mean that it's not something that could be brought in if we found that people wanted that.
Yeah, also the output format is a very generic format. That's our purpose. It's just JSON line files if people are familiar with that. And people can use their preferred visualization tools. If people are from data scientist community, they are probably familiar with pandas or NumPy, and they can use those to just load the result and visualize the output in whatever way they prefer.
I've got another question. I'm just going to pop this question up on the screen. Do you think there will be ever an option to add custom dialogues like in bot framework? That's a good question.
So I've got some familiarity with the bot framework. I knew a lot of the folks over there. We worked with them extensively in the past. My team also is responsible for the speech SDKs and some of the vision SDK work. And so I like to think of this as there's multiple layers to the system. And so at some layer, you're just using the web services. At some higher level, you're using sort of convenience libraries. And at some higher level, you're using more sophisticated, complete framework systems that have an opinionated way about how your application will end up landing and looking. The bot framework is more in that latter, where it has a very, the team would call it an opinionated approach to building a chat bot that has a particular look, a particular feel, and a particular architecture and dynamic. Whereas what we're showing here is at a little bit lower layer, where you're using the service a little bit more directly, you have a little bit more flexibility, you have a lot more responsibilities though at the same time. And so these two things can be integrated and work well together. And I'm sure there are future product plans across different teams at Microsoft to try to make sure that we have the right offerings at higher levels. Things like you might look at AutoGen or semantic kernel or things like that that have a slightly higher level of abstraction than what we've showed here so far.
Cool. I have got one question. So you shared your links on your slide. It's very helpful. Thank you very much. Do you happen to have a repository sharing your sample code just to help people get started with this code first approach?
Yeah, so the sample that we talked about adapting, that's public in the GitHub repository. And so I think probably we can coordinate getting all the links that were shared in the presentation to the audience. We don't have the Treeholics as kind of a custom example used for this case, and it's pretty lightweight, but it was based, and we shared sort of what we adapted from that sample. So I'd really suggest going to that AI Studio Copilot sample to get started.
Got you. We've got one suggestion from the audience today in terms of what the chatbot should be called. Spruce.
I love it. We're going to have to collect these. Thank you, Tori.
I think that's it. We don't have any other questions. So thank you very much, speakers. Thank you very much for that talk. I enjoyed it, certainly. Yeah, hope you enjoyed it as well.
Yeah, it was a lot of fun. Thanks for having us.
Yeah, thank you very much on behalf of Global AI Notes as well. So yeah, thank you.
All right.
Thank you.
Thank you. Have a good one. Bye.